So beginning with writing your half reactions. Before we get into this, it's firstly important to remember why is it important to write half reactions. So as I said firstly, before we get into it, the half reactions is giving us more information than just your ordinary chemical equation. The half reaction is telling us how your oxidation number is changing, and it's also telling us how many electrons are gained or lost in the process. Okay? But half reactions are also going to help us in the next topic that we get to, which is we can actually balance any chemical reaction using the half reactions. Okay, so remember when we were given very long chemical equations, let's quickly look at an example. Let's give you one so let's say we had this chemical equation and I wanted to balance it, okay? Usually in our previous topics, we would say, well, we need to balance this by writing down every element we have, and then we would write the products number of elements, and then we'll write the reactants, and we'll try and make that number the same, okay? But if we use oxidation numbers, aka our half reactions that we're now going to learn how to do, then there's a trick that we can use those half reactions to get the coefficient values that go in front of this reaction. In other words, we can use the half reaction to balance it. So that's why it is important to learn how to write those half reactions. Now, before we actually get into that, I just want to quickly show you an important table that I've been referring to, but here it actually is. So this is a table where we've got special ions. So you can call it special ions or compounds. Ions is better because remember an ion has an overall charge. Now if you look at each of these compounds in here, you'll notice that they've got a charge above it. For instance, if we look at nitrate, it's got a -1. If we look at peroxide, which is O2, it's got a 2 minus. If we look at sulfate, SO4, it's got a 2 minus. So these are special ions that when you ever see these types of compounds coming out, you automatically know the charge on it, okay? This is a very important table, especially when you want to find your oxidation number, because for instance, let's say they gave you a substance like SO4. If you didn't know that this is an ion and it's got a 2 minus charge on it, you would go and say, well, whatever sulfur is plus whatever oxygen is must give me 0. And the 0 is incorrect here. Why? Because this is supposed to be -2. So this must equal to -2. So just be aware of this table. It's a very important table. Make sure you write it down and become very familiar with the different compounds and the charge that you see on here. Alright, and then I've also just got the chemical periodic table so that I can refer to it when we get started. So let's just jump right into an example where we look at a half reaction. I'm going to do 2 examples and then we'll talk about, or I'll give you some examples to try on your own. Okay, so we're going to take this one very slow so that you can see clearly what I'm doing every single step. Now let's start off with an example where we have a chemical reaction. So we have copper plus silver nitrate. Okay, and this is giving me copper nitrate plus silver. Alright, now the question here is, let's just write that down. The question is we want to write the half reactions. Write the redox half reactions. Okay. So at this point, if you feel like you know what to do, you know the steps, pause the video and attempt it on your own, and then unpause and check the answer. If you don't know what to do, I'm now going to start with a few steps to get you started, and we'll build up until we get to the answer. So whenever you're given a chemical reaction, and it's the section of redox question, the first thing you always want to do is you want to go and write down the oxidation number at the top of every substance in this chemical equation. Okay? Not forgetting our rules that we learned in the very first lesson. Okay? Rules like if you've got a pure substance, the oxidation number is automatically 0. If you've got a compound and it's a neutral compound, like this, then you know that those numbers, the oxidation numbers, they must add up to give you 0. If you've got an iron, what is an iron? This table. If you've got an iron, you know your oxidation number must add up to give you the charge. Okay? So using those rules, you can now maybe pause the video and try it on your own. So now I'm going to go through the answer. Let's have a look at copper. Copper is an element on its own. It's a pure substance, therefore it should have an oxidation number of 0. Can we see another pure substance? Silver, right? On the extreme right. This is a pure substance, so the oxidation number should be 0. And then if we now look at silver nitrate, okay, let's have a look at this compound here. I'm going to write it down at the bottom again so that we can go through it. Okay, let's do it in blue. So if I've got silver nitrate, and we want to figure out what is the oxidation number of silver, what is the oxidation number of nitrate. Now firstly, these two elements coming together, this is an example of a neutral compound. So whatever the number is for silver, whatever the number is for NO3, this must equal to 0 if I add both those numbers. Right? Now you also may be wondering, why am I combining nitrogen and oxygen together? Why am I not saying what is the number for nitrogen and oxygen separately? Why am I referring to it as a single substance? Well, this comes from our table again, NO3. If we look at this table, you'll notice that NO3 is nitrate, and this is a special compound, right? So we can refer to it as a unit. I don't have to separate nitrogen and oxygen. I can simply keep them together because I know that the overall charge of it is -1. Where am I getting -1? From the table, right? It's special ion. So from the table I know that NO3, from the table I know that NO3, it has a charge of -1. So I'm going to go ahead and write -1 above it. Right? I don't know what silver is, so I'm just going to leave that with a question mark. But I know if I add the question mark and the -1, I need to get an answer of 0. So this is a normal equation that we can use. Let's call the question mark x plus -1, giving me 0. So x plus -1 equal to 0. X must therefore equal to +1. So from here we figured out that silver is +1 and NO3 as a unit is -1. Right? Now let's have a look at our other compound there, which is copper nitrate. Right, I'm going to write that on the side. So we've got Cu, and then we've got NO3, but we've got 2 of those. Okay. Now again, we have to go through the same process. I know that NO3, one of it is supposed to be -1. I don't know what copper is, but I know if I add both of this, I must get an answer of 0. But you need to be careful because this is a bit tricky, right? You've got 2 nitrates. How do we know that? Because we've got a subscript saying 2. So when you're writing your equation here, you need to do it as follows. We've got a question mark, which I'm going to call x plus. I know nitrate is -1, but I've got 2, so I need to put a 2 in front of my bracket. Okay, so x plus 2 nitrates, which has a oxidation number of -1, must give me an answer of 0. So if I solve for this, x minus 2 equal to 0, x must therefore be equal to +2. And we've now solved for copper, that copper has a oxidation number of +2, and nitrate as a whole has an oxidation number of -1. Be careful about that, right? It's -1. Okay, so we've now solved for the oxidation number of every one of these elements here. I'm just going to quickly erase the working out here so that we can make more space to write. Okay, so we've got the oxidation number at the top of each of these elements. What do we do next? Next, we need to write down what is going on. What do we notice about the oxidation number? Is it increasing? Is it decreasing? Which substance is it increasing? Which substance is it decreasing for? So let's go ahead and do that. Let's have a look at copper first. So if we look at copper on the left-hand side, it has an oxidation number of 0. but it becomes +2. So we can say for copper, the oxidation number changes from 0 to +2. Okay, let's interrogate that a little bit more. What does this mean? So it means you're going from a number of 0 to +2. And the only time that this number can increase, so this means that your oxidation number, which I'm going to write for short as ON, that stands for oxidation number, is increasing. The only time your oxidation number can increase is if there is a loss of electrons. And what is this regarded to be? This is going to be a oxidation. So copper is undergoing an oxidation reaction. How did I know that? Because remember that rule we learned? Oxidation has an O, loss has an O, so we know it's oxidation. There's another abbreviation or acronym that you can use, and I think it goes like oil rig. Okay, oxidation is loss, reduction is gain. So whichever you use, it's fine as long as you are able to correctly identify it. Okay, so we've just found out that copper is undergoing oxidation. While I'm here, I'm going to write down my oxidation half reaction. Okay, my oxidation half reaction. Let's write it down. Now remember, before I get into writing down the oxidation half reaction, there's a rule that we need to remember. Where do I put the electrons? Oxidation means that I'm losing electrons. So do I show that electron on the left-hand side or the right-hand side? That's the first thing. Well, we learned something. We said that because oxidation has an O in it, product, the word product has an O in it as well, it goes on the product side. And if you think about a chemical reaction, where is your product shown? Usually on the right-hand side. So my electrons need to be shown on the right-hand side. Okay? The other important thing I just want to quickly remind you verbally about is that whenever we're showing a half reaction, the point of it is to show how the oxidation number is actually changing. But we won't write down the oxidation number if it's 0. We write it down for everything else. We only do not write it down if it's a 0. So let's do it. We're going to say that we're going copper. Copper started off as 0, so I'm not going to show the 0 at the top here, right? So copper became copper 2 plus 2, and I'm showing how many electrons did it lose. Now remember, how do we know how many electrons it lost? We went from a number of 0 to not +1 but +2. So we took 2 jumps ahead. So it must be 2 electrons, right? So copper lost 2 electrons. That's how we show it. And this is a completed half reaction for the oxidation. We still have to do reduction, but let's figure out which substance is undergoing reduction. So this is just one part of the answer, right? Now, let's look at silver. Silver is +1 on this side, and then it became 0. So silver, the oxidation number is decreasing. So let's write that down. For silver, you're going from +1 to 0. So in this case, the oxidation number is decreasing. In other words, there's a gain of electrons, right? So let's go ahead and write down. So this means it's undergoing reduction. Let's write down the reduction half reaction. Where do I show the electrons? On the right-hand side or the left-hand side? Well, R reduction, R for reactant side. So we know it's going to go on the reactant side, and that is which side? Let's look at this at the top here. This is my product side. This is my reactant side. Okay, so reactant side is usually on the left-hand side. Not usually, it's always on the left-hand side. So this is the left-hand side. Now let's talk about how many electrons did it gain. If we're going from +1, here's the number line. Here's 0, -1, +1, +2, and so on. If we started off at +1, so we're standing here, we had to take one jump to get to 0. So we gained only 1 electron. Okay, I like to think of it as a number line. It's easier to remember. So let's write it down. Silver. Let's go back to the equation. We started off with a +1. So I'm going to say silver, which had a +1. It gained 1 electron. I'm writing it on the left-hand side, and it then became, if I go back to my equation at the top, I can see that it became silver with a 0. But because it's a 0, I'm not going to write 0, I'm just going to write silver. This is the reduction half reaction. So now you've successfully written your copper half reaction and your silver half reaction. Nothing too complicated, it's just getting your numbers right, getting the number of electrons gained or lost correct. Okay, so I hope this example helps. Not too long of an example, but I do hope it helps. I'm going to give you one more example to try on your own. You can go through it, and since we're not having a lesson live today, try this one on your own, and if you're done, actually even send me your working and I'll mark it and I'll see if you've got it right or wrong, and I think it'll help also showing me how you guys are thinking, what you're struggling with. If you have questions, feel free to ask. So here's an example for you to try on your own. So here we've got NH3 plus O2 giving us NO2 plus H2O. Okay, so this is an example. I would like you to try this example, and tomorrow when we meet, we will go through the answer for this. But if you actually do this question today, feel free to send me your answer, and I will actually mark it for you and tell you if you're on the right track or not. Okay, so take care, guys. I will see you tomorrow live.